Let's see here. We are on section 5.7 of the notes, honors geometry, and this is page 2. All right. Let's see here. What do we got? Given a triangle with vertices, all right, so we have 3 vertices, determine whether the triangle is a right triangle. All right. Well, let's think about what a right triangle is. All right, what does it mean to be a right triangle? It means that we have a right angle. All right. Um, what else can we say here? Right angles. Well, a right angle is a 90-degree angle. That means 2 lines are perpendicular, right? They form a 90-degree angle. And we kind of talked about how do we determine whether we have a 90-degree angle or not when we use slopes. So for this section, it's going to be all about slopes. Use slopes. Hey, what was the slope formula? It was m. We used the lowercase letter m. M equals y2 minus y1 all over x2 minus x1. Right? The rise over the run. So let's just look at an example. If I have a graph, all right, maybe this is some graph, and I have a line in that graph. Maybe it looks like that. Let's say the slope on this guy, I don't know, it's a negative slope. We're going to call this -5/2. All right, I'm just making up a number now. So this line coming through right here, if I want that line to be perpendicular, so if I want this to be a 90-degree angle, well, we already know what that slope is going to be, right? We had a 2-word phrase. It was opposite. I'm going to abbreviate. I'm running out of room. Opposite and reciprocal. I think I spelled that right. Been teaching this for 5 years, and I just think I still spell it wrong. So it's the opposite and reciprocal slopes. All right, so look at the -5/2. It's negative. We need to make it positive. All right, the reciprocal of any fraction, you just flip it upside down. So the opposite and reciprocal slope is going to be +2/5. All right, so that is how we determine if we have a 90-degree angle. Now, what I'm going to do is I'm going to use the slope formula 3 times on this problem. I'm not going to write it down every single time. I'll keep it up top there in purple, but we're just going to skip that step just to save us a little bit of space here. All right, so the slope of AL, here is A, here is L. I'm using the first two. Y2 minus Y1, so I get 6 minus -2. All right, that's my top. That's my Y value, the rise, I guess. All right, and then -3 minus 4. All right, so we got everything plugged in correctly. Let's just, I don't know, evaluate it here. Minus a negative is a plus, so we have an 8 on top, and we have a -7 in the denominator. All right, so the slope of AL is just 8 over -7. So what is perpendicular to that? It would be +7/8. So if one of those slopes is +7/8, we're good. All right, we just need to check them. So the next one, the slope of AH now. So we'll do AH in blue. So I need point A and I need point H. So this is Y2 minus Y1 again. So 3 minus -2, right? All over the X value is 7 minus 4. All right, minus a negative again. That's going to be 3 minus -2. That's a 5 on top. And we have a 3 on bottom. All right, so those are not opposite reciprocal. So we automatically know AL and AH are not perpendicular. So here, I'm just going to write that. I'm going to say AL is not perpendicular to AH. All right. Now, we got one more. Check the slope of LH. So I need point L, and I need point H. So I got 3 minus 6, that's on top. And then I have 7 minus -3 on bottom. That gives me a -3 on top. And 7 minus -3 gives me a 10. All right. So let's take a look at these. These two are not opposite reciprocals, so we can say AH is not perpendicular to LH. All right. Now, let's compare the top one and the bottom one. Running out of colors here. All right. Are those opposite reciprocals? Well, no. No, they're not. So we can say AL is not perpendicular to LH. All right. So what this tells us is none of those three sides of the triangle are perpendicular. All right. That means there are no 90-degree angles. That means there are no right angles. Therefore, this is not a right triangle because there are no perpendicular lines. All right. And that one's done. All right. Let's see, I got 7 minutes. Can I do this next one here? Prove the triangle whose vertices, prove it's an isosceles right triangle. All right, so there are two things going on here. An isosceles right triangle. So we have to show two things. We need to show two things. What do we need to show? Since it's an isosceles right triangle, here I'll just do the slopes first. Show that there is, I'm gonna say show two segments are perpendicular. All right. And we do that with slopes. All right. Second thing we need to do is we need to show wow, I used the wrong two. That's embarrassing. How about this? Let's say show two segments are congruent. All right. So two things. Let's see if we can do it. First things first, I'm going to plot the points. All right. And I'm going to tell you why I'm going to plot the points in a moment because this is going to speed things up a lot. So I'm running out of time. So let's see, I got 4, -1. That means I'm going to go 4 to the right, 1 space down. If you mess this part up, we're just, you might as well just, I don't know, not do it. So we have to be so careful when we're doing this. We're at 5 and 6, so 5 to the right, 6 up. And then we're at 1, 3. 1 to the right, 3 up. All right, so this is triangle A, B, C. All right. So keep in mind, we're trying to show that two lines are perpendicular. We can save some time here. Which two lines look like they might be a right angle? All right, which two lines look like they might be perpendicular? We'll look at CB and look at CA. All right. They look like they're going to be a right angle. So those are going to be the two that I'm just going to confirm. That might save us a little bit of time. So here we go. I'm going to say, we do this in red. So first things first, I'm going to say M, lowercase m, the slope of CB. Right? That's going to be equal to, all right? Don't waste your time with the formulas when I give you a graph. All right. Slope is rise over run. We are going up 3 spaces. We're going to the right 4 spaces. So the slope of CB is 3/4. All right. Let's do the same thing. The slope of CA. The slope of CA is equal to, we are going down 3 spaces, going down 4 spaces, going down 4 spaces to the right, 3 spaces. So our slope is -4 thirds. All right. So notice 3/4. Again, notice 3/4 and -4 thirds are opposite reciprocals. Man, my computer is struggling. There we go. All right. So we could say CB, why are you struggling to write? Come on. So CB is perpendicular to CA. All right. So step 1, done. Show that 2 segments are perpendicular. We did that using our slopes. Step 2, show 2 segments are congruent. Well, look at CB and CA. Those look like they are going to be the 2 congruent sides. So let's plug them into the distance formula. All right. So I'm going to say the length of CB is equal to the square root of, well, if you look at the x values, we're going to the left and right 4 spaces. So this is 4 squared, and we're going up 3 spaces. So we're going to have 3 squared. All right, that's going to equal the square root of 16 plus 9. All right, and that's going to be 16 plus 9 is the square root of 25. Well, hey, look at that. The square root of 25 is just 5. So CB has a length of 5. Let's look at CA now. CA is equal to the square root of, let's see here. We're going to the left and the right, 3 spaces. So I'm going to put 3 squared. My computer knows it's almost the end of the school day and it's trying to slow me down here. That's what's going wrong. There you go. So we got 3 squared. All right, plus -4. -4 squared. All right. Which is going to be equal to 9 plus, look, what is going on? This thing is, nine plus 16. Okay. Which is the square root of, oh, guys, I'm getting really annoyed right now. Square root of 25. The square root of 25 is 5. All right, I'm typing the rest. I can't handle this. All right. So CB is congruent to CA. All right. So we showed 2 sides are congruent. So let's just kind of recap. We showed that 2 sides of the triangle form a right angle. So it's a right triangle. And we showed that 2 sides are congruent. So it is an isosceles triangle. Therefore, this is an isosceles right triangle. All right, there we go. Now, there's one more page here. I'll just make another video for that one. You're not going to like the next page. All right, this one, this is kind of a challenge problem. Before you ask, no, you're not going to have one like this on your test. All right, so it's still good to see this kind of problem, though. This is why you're in honors geometry. This problem, to me, is an honors geometry type of problem. This separates us from, the non-honors classes. Something like this is a very difficult problem. So I'm going to try to do it in the next video. But right, this is all we have. All right, so we'll see you guys in the next video.